Hello friends, I'm back with the new content in NLP. So today we are going to move on with the models of the transformer, and I will be dive into the next part. So it's about the introduction and in-depth analysis about the function called pipeline that we have already used. We will be diving deeper into the function pipelining, and we will talk about how it is implemented. So let's get started. As you saw in chapter 1, transformer models are usually very large with millions to tens of billions of parameters. Training and deploying these models is a complicated undertaking. Furthermore, with the new models being released on near daily basis and each having its own implementation, trying them all out is not an easy task. Here comes the transformer library. The main goal is to provide single API through which any transformer can be loaded, trained, and saved. The main features can be explained under the three topics. First one is ease of use. In which case we can see that downloading, loading, and using state-of-art NLP model can be done in just few lines, and it's also flexible. At their core, all the models are either implemented in PyTorch or in TensorFlow, so we can easily handle them. And also another main feature is simplicity, as it follows the concept of all-in-one file, and all the models are defined in a single file so that the code itself is understandable and hackable. This chapter will begin with an end-to-end example where we use a model and a tokenizer together to replicate the pipeline function, which was introduced in chapter 1. Next, we will discuss the model API, and then we will dive into the model and configuration of the classes. So let's get started with that one. So in this page you can see that they have also given you a YouTube link, so you can go through that as well. So this chapter is all about the coding part, which I will explain with the help of the Colab file. So briefly I want to cover the theoretical concept, which is very important one, and all that is mentioned in this figure. As we have used the pipeline function for various purposes like sentiment analysis, for question answering, and for unmasking the master word. All those pipeline model or the function will have these steps underlying it. So first task is tokenizing, where we will take the raw text like a sentence, and the tokenizer will divide that raw text or sentence into the smaller tokens, which may be the word separated by the space, or the words which are separated by some special characters, and so on. And then as the model can only understand the numbers, those tokens should be changed into the numbers, or which we call them as input IDs. So all the tokens which are generated are converted back into the input IDs, which are just the list of numbers to represent those tokens. Now those input ID will be given as an input to our model, and model will find the logits from this input ID. So logits is a raw scale value which is assigned to the numbers or the tokens, so that we can evaluate our output, or we can find out the words or the token which we need in our sentence, or which we are going to predict or mask. Yes, these logits are the raw scale. So for them to predict something, we need to change them into probability distribution. For that, we need the post processing step, which is done by the softmax function, and this softmax function will take logits as the input and change that logits value into the probability distribution for the sake of prediction of the required words. So this is the underlying technique behind the pipeline function. So let's go to the Colab file and let's see how this pipeline function works in detail. Let's move on. So for this one, we again need to install some dependency or the module that we need. So let's install that. As we already know, we need transformer and sentence piece from it. So we have to install that one. After installing that one, we need to import the pipeline, and from this we will be using sentiment analysis pipeline for classifying the given sentences. So here we have given 3 sentences and we are supposed to classify them, either they have positive sentiment or they have the negative sentiment. So let's get started. So here we are directly using the pipeline function, sentiment analysis as the pipeline for predicting if the given sentence are positive or the negative one. Now our model is being downloaded. Yes, so it predicts the label for each sentence. So first sentence is classified as positive, second is negative, and third one is again classified as positive. Now let's dive in depth about how this pipeline works. So as we all have already seen, the first step is the step of tokenization. So let's import auto tokenizer, and then this checkpoint is the weight of the model. So as in case of sentiment analysis, the default model is a distill based uncased fine-tuned SST to English model. So we will import it as our checkpoint, and then we will use auto tokenizer of that checkpoint, as we need to use the tokenizer that is used during the pre-training phase. We will use the same tokenizer which is the checkpoint, which is the tokenizer used for our checkpoint in the tokenizer. So let's import that, and after that our raw inputs, which we have already given above, let's give them as the raw inputs, and after that we are going to tokenize those raw inputs with the help of the tokenizer function. So the first argument are the list of raw inputs that we are going to pass in it. Second is padding. So this padding is required, as we can see that the various sentences are of different length. To make them of the same length, so that it will be easy during matrix multiplication or matrix implementation, we provide them with the padding and make the sentence of the equal length. And then this truncation is true is for the scenario that if our sentences are longer than the capacity of the model, it will truncate the length of the sentence as per the requirement, and return tensor is of PyTorch type. And then we will print the value inputs which we get as a return from our tokenizer function, and you can see that it is our dictionary having input IDs and attention mask. So input IDs are again the identifier for each tokens, and attention mask represent whether there is padding or not. So whenever there is padding, our model won't provide any kind of attention to those paddings, as they are not the important part of our model. And then let's import the model. So yes, our checkpoint is this, and we need to import our pre-trained model from that checkpoint. And then after importing the model, we will pass the inputs to our model, and then we will try to print out the logit shape or output of the model. So output of our model is 3, 16 and 768. Let's try to understand that. So 3 is the batch size. We have 3 sentences. So here is 3, and 16 is the length of the bits that are used to represent the tokens, and 768 is the let me check, 768 is the hidden size. So it is a vector dimension for each model input, 768. And then what we need to do, we need to obtain the outputs from this model, and output, as we have already seen, will be in the form of the logits. Let's check its shape. So we can say that its shape is 3, 2. So 3 is the input number of sentences and 2 is the possible outputs, as in both the case it is either true or it is either positive or negative. So when we see its value, we can see that for first sentence its value is minus 1.56 and 1.61. For second is 4.16 and minus 3.3, and for the third one it's minus 4.15 and positive 4.45. So this is the logit value, which is a raw value, and it doesn't make actual sense for predicting the tokens. Now we have to take the help of the software function so that we can change the logits into probability distribution. So let's apply this function and see the result. So this is the final prediction after applying the software function. So we don't have any label, so which one is which label, this is not explicitly specified. What we can do is that we can convert those ID to label using this line, and we can find that 0 is negative and 1 is positive. So first value is for the negative prediction and second value is for the positive prediction. So first sentence we can see that its negative value is less, so it is positive prediction. Second is negative, and again third is the positive one, as we have got from the pipeline function already over here. Let's take another example, or before going on to that, we can also change or play a little bit with those things. Let's remove some sentence, change this to I love this so much, and then I hate hugging face for my life. So what we can see the change in the length. I hate, or what we can do, we can remove this one and again see the attention and the padding. So if they are of the same length, there is not any kind of padding, and if we have different lengths, I love this so much from my heart. When we have different length, we can see there is the introduction of padding. You can go on and try different option and play with your own. Now yes, dot size will change, number of representation will change as well, and every prediction will change, as we can see. Yeah, but the label will remain same, both positive and the negative one. In the same way, let's try some more things. Like we can see that except for those like sequence classification, we have other option as well, and those things are not given here. So I will be doing one more thing for masking the sentence. Let's go through example. Yes, for using that, we again need to import auto tokenizer, and for masking purpose, our language model will be Robota for masked language model. Let's import those one, and again we import tokenizer and model, and we give input in the tokenized form like the capital of France is, and we will mask that word, and we will try to print the inputs. So yeah, input will give dictionary as an output, as we have already seen, consisting of first input IDs followed by the attention mask, and then next step will be to pass those inputs to the model, and we will get logics as the output, and after that we need to retrieve the index of the mask, and with the help of that index we will find the token ID of our mask word, and we will use that token ID to decode our actual word. So let's have a look at it. So we will get the logics in the tensor form, and then we will find the token ID, and from that token ID we will get the predicted word as Paris. So in this way we can implement the various pipeline function from the scratch, dive into the depth what happened behind the pipeline if you want to have a look at it. Otherwise, if you just want to implement the thing, we can directly use pipeline function. So this is all about it. I will be uploading more content in the next topic called models in my next video. Thank you very much.